Object-oriented programming is how we program in the real world. It makes learning new code bases and adding new code to legacy code bases a lot easier. My name is Adi, I'm a software engineer at Amazon, and in this video I'm going to explain how object-oriented programming works in a way I wish it was explained to me. Now, object-oriented programming comprises of classes and objects. We're going to take a car manufacturing plant as our example here. Now, classes are going to be the blueprint on how to make the car. And then once you've made a car, like car 1, it's going to be an object, an instance of that class. Now, inside each class, you're going to have constructors. They tell you what inputs you need to give to get that car object out. But you're also going to have methods, which are functions related to that car, like drive, brake, all that within that same class. Now, 4 pillars make up object-oriented programming, which are abstraction, encapsulation, inheritance, and polymorphism. Abstraction means that the code you write must be so well written that the user that eventually uses that, which will be another developer, doesn't need to know how the code works. They just need to know what inputs come in and what outputs come in. If you've ever worked with an API, you don't know the backend service, but you just have to put in these inputs and you get an output. When you drive a car, you need to push down on the accelerator. You don't need to know what's happening in the engine and under the hood. You just need to know that you push down the accelerator and the output is your car goes forward. Now, you next have encapsulation. Encapsulation makes debugging easier, and all it really means is all the functions and variables related to that class stay within that class, and they don't just come out from anywhere. It makes debugging easier because once you know where the issue is, you can find it easily. And when you're making changes to values like the speed, like the top speed your car can run at, you can easily see every line of code what exactly was changed. Next, you have inheritance. Now, you might have a car class, but you might also want an SUV class and a minivan class and a sedan class. So you'll have a child class of the car class, which basically means all SUVs are cars. So they extend the car class, but not all cars are SUVs. So everything a car can do, an SUV can, but an SUV might have more things it can do, like extra legroom, extra trunk space. Now, a lot of people don't always use inheritance. They sometimes use composition, which are more like you set up contracts or small methods that you can add in to your new classes as okay, this can also do these extra bits of functionality, which is very similar to the builder pattern if you know design patterns. Last, you have polymorphism, which is between runtime and compile time, which runtime means that there might be 2 methods, 2 functions with the same name, but based on whichever one is closest to the child class goes first, and compile time is based on whichever one has the correct inputs. That's all there is.